What is up? How you doing, brother and sister? You know what I'm saying? So now today we're gonna do a trig inverse and integration plus. So you have an integral, see like this integration, and then you have a trig inverse. Integration, and then you have a trig inverse with a certain function. Integration, trig inverse. Okay, whenever they say arctan, arc sine, or arc of any trig, it means that's a trig inverse. So when you say arctan and tan inverse, means if you say this, so what I'm saying, it means this tan inverse of whatever function you have, and if you say arc tan, it's the same thing. So if somebody say arc tan x squared, means it's tan inverse of x squared. Same here, tan inverse of cos 3x. So now let's get started, man, without wasting time. Before we get started, you know what I'm saying, don't forget to support, my merchandise. You can get it online, you know what I'm saying. You can click the link below to my shop, online shop. You can get these products, you know what I'm saying. And also, we got this products too. We got all this Dynasty and all this stuff, you know what I'm saying, you can get from my size. Now let's get to the business, you know what I'm saying. So now let's start with the first question. First and foremost, before we get to the integration of parts, now let's start with the inverse of trigonometry. Let's start with the first. If somebody give you, let's say, differentiate, let's say tan of a function, tan of a certain function, let's say x cubed. So this is function. So what you do, take this function, then differentiate. So you say, oh, I'm going to take this function which is in here and then differentiate. So when I differentiate, it means d3 is going to come back, it's going to be 3, and then run my x, 3 minus 1 equals 2, and they say 1 plus, take this function, then it's square, means say x cube exactly, and then square. That's how you differentiate trig inverse. So this is going to give you 3x squared over 1, and this is going to be x power 6. So this is a formula here. You take your function, differentiate, and the 1 plus function square. So same with the sine. So if somebody give you, let's say, differentiate sine inverse or sine of function of, let's say, e x squared. So what you do, differentiate all these function which is in here. Means you have to differentiate whatever function which is in here. When you differentiate this, is going to give us 2x. Means you're going to take this one, differentiate. It's going to give you 2x, and then write exactly, which is going to be x squared, and then over, if you don't want to say this part, go to the differentiation of exponential function, you know what I'm saying, go to my previous video, and then you say for the sine is going to be square root. So there's a formula here, get to you 1 minus, take your function, then square. What is your function? Our function is e x squared, and then what you do, you square. So that's what you get, you know what I'm saying, and this is going to be x power 4. So is finally, it's going to give you 2x e x squared, and then you have a square root 1 minus e x power 4. You know what I'm saying? So for the cos also, you're going to do the same approach. The only difference between cos and sine, the cos you put negative over there. So I'm saying, so that's how you differentiate trig inverse. Now let's go and do the first question. So for this cos is easy. For the cos, for example, if somebody give you differentiate let's say ln of 2x. So this is cos inverse or arc cos. So what we're going to do for cos is going to be almost the same as a sine, but the only difference here you put negative, you know what I'm saying. So what I'm going to do, I'll say let's differentiate the whole of this function. Now let's differentiate. So you can even do it aside. Say, okay, let me take this function, differentiate. Okay, so I want to take my function. What is my function? My function equal to ln 2x squared. I can even take it aside and let me differentiate. Means I have to differentiate and then write the answer on top. Okay, so how do you differentiate ln? Ln, this is going to be 4x, and then 2 minus 1 equal to 1, and then you over exactly the way how it is. 2x squared. That's how you differentiate ln. Take whatever you have here, differentiate is going to be 4x1, and then over exactly. So now you can simplify. 1x and 1x go, so it's going to be 4 over 2x. Okay, by 2, 1 by 2, 2. So 2 over x. Oh, okay. So if I differentiate all of this function, it's going to give me 2 over x. All right. So now this is going to become, means when I took this function, I differentiate, give me 2 over x. But for cos, it must be negative here. See, that's a formula. and then you square root. I'm saying square root, and then you say 1 minus square your function. What is the function? Ln 2x squared. Ln 2x, and then this square, and then what you have to do, you have to square also outside. You know what I'm saying? So you can leave the way how it is. Do not say this when you say ln 2x square is not equal. Let me just say this is not equal to ln of 4x power 4. No, you cannot do that. You know what I'm saying? It's not equal. Leave the way how it is. But this is equal to ln of 2x squared times ln of 2x squared. You know what I'm saying? So you hear what I'm saying? So this is equal, but it's not equal to. So you cannot only multiply. This is unacceptable. So now I believe you understand now how to differentiate trig inverse. Now let's go to the how to integrate by parts, because you cannot integrate this by parts if you don't know how to integrate this trigonometric integral. That's what I say, this is trig inverse but by parts. Now, so I don't need this anymore. You know what I'm saying? So if you come from that, so now we should be able to integrate this question. So now the question is, how I'm going to identify this is trig inverse? So like I say, when you solve trigonometry, especially trig inverse, you're going to identify. The more question you do, the more just by looking at the equation, you know, oh, this is trig inverse. For example, I say from beginning, whenever you integrate by parts, if you have an integral and then something with tan inverse, that's a trig by parts. You know what I'm saying? Or it could be ln, or it could be exponential. Most of the time, these are trig by parts. So whenever you see integral with trig inverse, remember, that's integration by parts. You know what I'm saying? You got integral, trig inverse, integral, trig inverse. Arctan means arcsine is inverse. Now let's start for the first one. For the first one solution, let's start with the solution, the first one. So we got first and foremost, we're going to write the formula because we have already identified this trigonometric by parts. We have already identified. So now I'm going to write my formula. You can use either the first one or the second or the same thing. Okay, let me use the second one. For example, so the integral u dv formula uv in the integral. Now you switch. This is u dv. Now you say v du. Okay, you know what I'm saying? So if it's trigonometric by parts, let u equal to this term. So let u equal to tan inverse of x for this case. Okay, so the next things, so u equal to this, and what happens means u equal to this, so it means dv equal to the rest. So say dv equal to dx. So what you do, you differentiate this and then you integrate this. Okay, now when you differentiate this, it's going to give it to you, and when you differentiate this, we know whenever you differentiate tan inverse of whatever function, take this one, differentiate. When you differentiate x, it's going to give you 1 over, and this is going to be 1, and then we plus 1 plus square the function. What is a function? You square the function. Function is x. When you square, it's going to be x squared. Now we come here, we integrate this one. Integrate. When you integrate dv, you're going to get v, and when you integrate dx, it's going to give you x. Okay, so what we're going to do now, I'm going to take all of this and then put in the formula. Okay, cool. So now this is going to be integral. What is our u? Our u tan inverse of x. What is dv? Our dv equal to dx. Okay, u times v. What is our u? Our u equal to tan inverse of x. Okay, times v. What is our v? V equal to x. So I think it's good to multiply before. I encourage you all the time. Don't say tan inverse of x times x, because now this you might say, oh, this tan inverse of x squared, which is not true. You know what I'm saying? This tan inverse of x, or you can just put in a bracket. But most of the time, I will encourage put the x before tan x. So I can go like that. You know what I'm saying? So I'm gonna see. What is my u? My u equal to, shows me tan inverse of x, and then times of v equal to x. But I'll multiply this x, because if you say a times b and b times a, the same thing. You know what I'm saying? So I'll just put like that. Now we go. So now we say minus integral. What is a v? Our v equal to x. Okay, now we go du. What is a du? du equal to 1 over 1 plus x squared dx. You know what I'm saying? So now we go. So now this is going to give us, okay, x times 1 equal to x over 1 plus x squared. So this is going to be x times inverse of x, and then we minus integral. It's going to be x 1 plus x squared dx. Okay, so now you see it's not done yet. So what I'm going to do, I'm going to take these separately and then integrate separately. So now after we integrate this stuff here, it take us here. So we still got a problem here, man. You know what I'm saying? The problem is in here. So I'm going to take these separately and deal with it separately. You know what I'm saying? So now since you have this and you know how this works, I'll just erase the part, you know what I'm saying? Because you know the business. So I'm going to erase this so we know now. So I don't think we need it. So I'll just erase it. So let's make a space here. Okay, cool. So now I'm gonna say now, okay, let's make a space here, man, and solve this equation. So now I'm gonna take this on here, tag integral x 1 plus x squared dx. So what I'm gonna do here, nobody's gonna tell me like what you should do.